Hi, my name is Corey Holm, and I'm a CG specialist here at Chaos Group. Today I'm very excited to present V-Ray Next for Maya, and share a closer look at some of the latest new features that you can take advantage of using V-Ray Next. Together, we'll explore how the arrival of V-Ray Next for Maya can optimize your workflow, speed up your render results, and give you amazing looking images right out of the box. In particular, we'll discuss many powerful new features that V-Ray Next offers, such as how V-Ray Scene Intelligence can improve your workflow thanks to adaptive algorithms. V-Ray Next is also 25% faster on average and includes a fully redesigned APR that is packed with new features to make look development smoother, more flexible, and incredibly quick. We've also made drastic improvements to V-Ray GPU. We'll explore how you can achieve stunning production results using bucket rendering and Cryptomat on GPU for fine-tuned control and compositing. We'll also explore several new materials in V-Ray Next, such as the new physical hair material, the new Toon shader, and support for PBR workflows. Together, these improvements have culminated in making V-Ray Next smarter, faster, and more powerful than ever before. On that note, let's get started with the first major overhaul, V-Ray Scene Intelligence. One of our priorities is to make V-Ray more intelligent so that it's even more helpful for artists. In recent releases, we implemented smarter algorithms that gather data from the scene in order to optimize ray tracing calculations and speed up render times. In V-Ray Next, we've taken the concept of adaptive lighting, which was first introduced in V-Ray 3.5, and we merged this scene analysis technology with one of our most popular tools, the V-Ray Dome Light. By automatically optimizing the way V-Ray samples lights using the light cache calculation, the new Dome Light can speed up your renders by up to 7 times depending on the scene. Aside from performance enhancements, the adaptive Dome Light also removes the need for setting up skylight portals, so you can spend less time tweaking lights and focus on composing your final image. In fact, you'll automatically have even less noise in the darker areas of your renders thanks to the improved sampling, and the final result will be more accurate. Let's hop on over into Maya now, and I'll show you how easy the adaptive Dome Light is to use, and the impact it can have on your render speeds. Okay, here I have an interior sci-fi scene in Maya that is already lit. Now, aside from a few lights on the inside that are contributing artificial light to the interior, and a V-Ray sun shining in through the window, my primary light source here is just a dome light. Now to create a dome light, all you have to do is click up here on the dome light icon in the V-Ray tab. In this case, you can see over here that I already have a dome light set up for the scene. If I click on the dome light to select it, all I have to do is check the Dome Adaptive box here, and I can take advantage of the adaptive sampling algorithms in the scene. I can then use an HDRI of my choice for the lighting, and when I'm happy with my settings, I can simply switch to my camera and press render. The only other thing to make sure is that you've set the secondary GI engine to light cache so that the new adaptive algorithms can analyze the scene. Now I'll show you a video here that shows the difference that little Dome Adaptive checkbox can make for render times. As you can see, the render speed difference for this scene is substantial, simply with the help of V-Ray Scene Intelligence. Okay, now let's take a look at the new IPR. We know how important IPR is, so we decided to start from scratch. We've redesigned it completely in order to give it extended functionality, so now when you try it, it's going to feel much smoother. It will also update much faster when changing settings or moving geometry of the camera, so let's take a look at this comparison video so you can see the difference. You'll see right away that when I start the IPR preview here, V-Ray Next on the right starts up faster. And as I move the camera around, the IPR on the right provides a smooth and continuous update, compared to the previous IPR, which updates whenever I stop the camera. Moving geometry is also faster, and now I can preview the geometry as I rotate the engines on the ship. When moving geometry, I receive continuous feedback in the IPR as well, compared to the erratic movement of the engine in the preview on the left. Now in V-Ray Next, we've also enhanced IPR interactivity features. For example, we now offer the ability for you to isolate and preview different aspects of your scene, including specific geometry, individual shaders, textures, or even light sources. On top of that, you can now start the IPR directly in Maya's viewport without needing to open up the V-Ray frame buffer at all. To speed things up even more, we've also implemented NVIDIA's AI denoiser for real-time denoising and faster feedback. You can now even use it in the viewport and get nearly instant noise-free previews. Let's jump back into Maya, and I'll demonstrate to you how you can use these new features yourself. As you can see here, I've got this spaceship scene that is very similar to what I showed you in the IPR comparison video, only with a different lighting setup so that I can demonstrate some additional features. To start, let's go ahead and launch the IPR preview in the viewport by clicking the little V-Ray icon in the top left below View. We'll see the V-Ray logo appear as it loads for a second here. And there we go. We're now previewing our scene with IPR directly in the viewport. Now let's turn on the new AI denoiser and give it just a moment here to kick in. Okay, you can see the difference here as the AI denoiser smooths out the preview and it's getting rid of all of the noise instantly. Now let's get more acquainted with the ship here. I'm not a huge fan of the colors at the moment, so let's make some adjustments. I'm going to select the ship and then head over to the Blend Materials Base Material parameters, where I can make some changes to the ship's diffuse color on the front here. Let's first try out something different, maybe a shade of purple. That looks okay, but I think it still looks better with something a bit more red colored. I'm going to try a darker shade of red here. Now let's let the denoiser kick in here for a moment. And yeah, I'm liking that a lot more than the initial grayish brown color that we started with. Alright, now let's take a look at a few of the new debug shading modes we've implemented. First, I'm going to show you the lighting tool. This applies a nice standard matte gray material to the ship so that we can get a good feel for how the light is affecting our scene. Next, we can also preview the ship's wireframe image. And there's also an option to view the geometry's normals, along with a few other modes that you can explore on your own. I'd like to now show you one of my favorite new features of V-Ray Next for Maya, the Isolate Select mode. As I mentioned briefly earlier, this mode makes it possible to select individual elements of your scene, such as geometry, shaders, or even lights, and you can preview how they look separately. For example, as you see I'm clicking on these different pieces of the ship's geometry, I can now see how the shaders and textures are being applied to the different parts and how they look with the lighting. I can also click and drag to select whole sections of the ship's geometry as well. This is really useful for look development and texturing. Okay, let's open up the Hypershade editor and take a look at how the different shaders are being applied to the ship here. You'll see as I click on each node how it appears on the ship in the viewport, which makes it incredibly easy to debug the shading network. And I can quickly gain an understanding of how the materials are represented. Now let's minimize the Hypershade, and I'm going to open up the V-Ray Light Lister. You'll see as I select each light here that I can preview exactly how that individual light is lighting my scene and hitting the geometry. This tool is really helpful for understanding the lights in your scene and for composing a final image. Now, I'm going to close the Light Lister, and let's discuss one last major IPR feature that we've seamlessly integrated into V-Ray Next for Maya, and that's PLAYBLASTS. Visualizing your animations is now easier than ever, as we've introduced the ability to create playblasts directly in the viewport. With playblasts, you can easily preview your animations, and even denoise them using the NVIDIA AI denoiser for fast and smooth results. Let's head back over into Maya, and I'll show you how to get started with it. First, I'm going to turn off the IPR in the viewport here. Now, if I scrub across the timeline, you'll see that the ship has already been animated for our scene. Let's start the IPR on the viewport here again so we can get a better sense of how it'll look. And before demonstrating a PLAYBLAST, I'll also show you how you can easily adjust the PLAYBLAST quality as well. If we open up the render settings and head to the IPR section, scroll down to the bottom of the viewport dropdown and you'll see an option for PLAYBLAST quality. You can think of these different quality options like presets that make adjustments to the IPR settings for you under the hood. You can also set it to use IPR settings to set it up manually. I'm going to go with the medium quality setting. Now, let's close the render settings, and to generate a PLAYBLAST, simply right-click on the timeline and choose the PLAYBLAST options from the menu. As you can see here, this pulls up additional controls we can tweak. For example, we can also choose the display size and scale, and in this case, the PLAYBLAST will be about 50% of the size of the viewport. We can change the format type for saving the PLAYBLAST output, and drag this slider to set the compression quality here. Now all we have to do is click PLAYBLAST to see the result. Since the PLAYBLAST can take a bit to render, I'm going to pull up a video of a PLAYBLAST that was already rendered with a very similar setup here to show you what the results could look like. Okay, let's move on to the UI improvements. In V-Ray Next for Maya, we've made some brand new UI improvements in order to help simplify your workflow. In particular, we've created a GPU-aware UI for both the render settings and all of the V-Ray materials, so that rendering with V-Ray is now easier no matter which engine you choose, CPU or GPU. Let's open up a new Maya scene now, and I'll give you a tour of how the render settings look. Okay, now that we're in a new scene here, I'm going to open up the V-Ray render settings up top and just show you a couple of ways that the settings will change based on which production engine you're using. As you can see here, we're currently set to use the CPU engine, but what if I'm interested in using the GPU? In the past, V-Ray would not always hide the settings that are uniquely supported for each engine, so we've made that more clear now by making the settings adapt to whichever engine you choose. Now, you may notice that the render engine can only be switched from the V-Ray tab now, which makes things nice and simple. For example, let's click the drop-down here and switch the engine over to CUDA for GPU rendering. Immediately, you'll see how the settings update below. For example, there's appeared a menu for the V-Ray render devices selection, so you can manage your graphics cards. Now, you'll see that we're currently set to render using progressive sampling, but in V-Ray Next, we've now added support for bucket rendering on GPU as well. I'll go over the advantages of this option in more detail later, but I just wanted to point it out here so you know how to switch between the two different modes. Next, we have the render elements. Take a good look at this list here, and let's switch back over to the CPU engine for a moment. You'll notice that the render elements list on CPU is much larger. Again, this is due to the new GPU-aware UI, which makes sure that only compatible elements are shown for each engine. I'll switch back to CUDA so you can see the difference one more time. Now, let's return back to the V-Ray tab, and while we're on CUDA, I'm going to open up the Hypershade editor and create a brand new V-Ray material. On the right here in the attribute editor, take a quick glance at some of the basic parameters and controls. Now, as I change the production engine back to CPU, watch how the parameters for the same V-Ray material update automatically. For example, you can see that the opacity mode option has appeared because it's specifically available for CPU only. I'll change the engine back to CUDA one more time just so you can see how the material updates again. Alright, let's close the Hypershade and the render settings here now, and I'm going to demonstrate one more thing that we've added to the UI here with V-Ray Next, which is support for dragging and dropping V-Ray file types directly into the viewport. For example, I can take this spaceship VR mesh proxy, and I can drop it directly into the viewport to start using it. Let's zoom out here to see if I can find it. There it is. And now you can see that we've got a proxy that's loaded in and ready to use in our scene. I've also got a volumetric grid that I can drop in here that we made in Phoenix FD. Let's pan around to get a better look at it. And I should also note you're not limited to Phoenix FD files here. You can drag and drop OpenVDB files as well. Okay, that wraps up the overview of the user interface updates. Now let's move on and actually see what's been updated for the GPU. With V-Ray GPU, we've developed a brand new multi-kernel rendering architecture so that GPU production rendering is now twice as fast as before. This comparison I made should give you a quick sense of how GPU rendering has improved. Let's now discuss how V-Ray GPU Next supports far more high-end production features than before. To start, we now support volumetric rendering on GPU to create atmospheric effects like foggy environments. Now you can use tools like V-Ray's built-in environment fog to enhance the realism of your scenes. Let's hop on over into Maya and take a look. As you can see here, we've got a scene on Mars with a sci-fi spaceship landing. And to get started, I'm first going to open the V-Ray frame buffer, and let's start an IPR preview. While it gets going, I'm also going to pull up the V-Ray render settings just to confirm that we're on CUDA for GPU rendering. To start, I haven't turned on the environment fog just yet, just so we can get a good preview of our scene so far. Now, you can probably sense that the image is missing some of the depth and atmosphere that we'd expect to see on a Martian base, so let's see if we can fix that using the environment fog. First, I'm going to head over to the Override tab, and in the volumetric section at the bottom, let's check the Use Environment Volume setting on. Now you'll see that I've already loaded in a V-Ray environment fog previously, so let's take a look at some of the settings and make some tweaks to them. You'll see now as the fog loads in the frame buffer that the height is a bit too low, and we can make out what looks like the top of it right below the ship. I'm going to increase the fog height here to something like 2000. Alright, that's looking much better. Next, let's decrease the density or the thickness just a bit. And an easy way to do this is to increase the fog distance, which makes the fog more transparent. Let's try something like 7000. Okay, now I can make out the ship and the background details much more clearly. The scene is also looking too yellow and orange for my taste here, so let's try adjusting the diffuse color and maybe make it like a slight shade of blue. That should help to balance out the overall color of the image. Now, I'd also like to bring in a little bit more light into the scene. An easy way to do this is to check on the Scatter GI option, which will introduce some global illumination. Keep in mind this will slow down the render speed some, so I'm going to keep the bounces to 1 here, just to keep a fast preview. And that's really all there is to it. Now we've enhanced the realism and depth of our scene simply by using the V-Ray environment fog with the additional power of the GPU. We're also not limited to using the environment fog either. V-Ray GPU Next can now render volumetric effects like smoke and fire and includes support for Phoenix FD, OpenVDB, and Field 3D, all on GPU. In fact, we used volume grids that we simulated in Phoenix FD to animate our very own spaceship landing sequence. Here's a video of that I'll show you right now. On top of the volumetrics, V-Ray GPU Next also adds support for several new production features. As I mentioned earlier, we now support bucket rendering on GPU, but in addition to that, you can now generate mattes using Cryptomatte on GPU. Cryptomatte basically makes it really easy to quickly mask and correct areas of your render when using compositing software such as Nuke. In addition to support for cryptomat on GPU, we've also enabled the ability to denoise separate render elements. V-Ray does this in a way so that it preserves the integrity of your image when you're recompositing those elements together. Let's jump back into Maya now and explore some of these production features on GPU. Alright, we're back in a similar version of our scene here, and we've got some volume grids added as well. I'm first going to open up the render settings, and let's double check that I've got my production render mode set to CUDA for GPU. Alright, and let's head down to the sampler type, and as I showed you earlier, let's switch the type from progressive mode to bucket mode. Now we're ready to render using buckets on GPU. Okay, let's head over to the Render Elements tab now, and I'm going to select and add the cryptomat element for compositing. Now, on the right here in the Attribute Editor, you'll see that we have some additional options under the Extra V-Ray Attributes dropdown. Now, I'm going to leave these at the default settings, but if you wanted to, you could play with the ID type and change how the ID mats are determined. Next, let's add the denoiser render element. And again, I'm going to leave this on the default settings as well using the V-Ray denoiser. And now let's also add the GI and lighting render elements. But for each of these, I'm going to select this little denoise checkbox. This will allow me to denoise these render elements separately, but they'll still maintain their correct contribution of denoising, so we won't end up with any additional artifacts. Now, since I'd also like to be able to recomposite the beauty pass, I'm going to add the additional render elements to do so. Let's see, we've got atmospheric effects, background, reflection, refraction, subsurface scattering, self-illumination, and the specular. And now that all these have been added, we're ready to render. So let's close the render settings and open up the V-Ray frame buffer. And let's go ahead and start a render. Now we're seeing the initial light cache GI pass calculate, and then we should see the buckets appear. Okay, and now we can see the buckets kicking in on GPU. Now, since I don't want to waste our time here waiting for the whole image to render, I'm just going to show you that the cryptomat render elements are here while it's rendering. You can see these couple different ones. And now we can open up a version of the image that I've already saved. Okay, let's stop the render and let's open up the history panel here. And we'll load in the already completed render. Now, once again, I'll click the drop-down menu and let's take a look at a few of the completed cryptomat renders here. So you can see how we could use these for masking and additional controls in post-production. And we've also got the denoiser render element, the denoise GI and lighting elements here, and a bunch more elements that we can choose from. Let's go ahead and take a look now at the final effects result. And before we move over into Nuke to explore compositing, I just want to quickly demonstrate how to use the brand new lens effects. In V-Ray Next, we redesigned the lens effects for bloom and glare in order to make them simpler and easier to use. So let's hop back into the scene and I'll show you how they work. So first let's open up the lens effects by clicking on this little lens icon, and you'll see the effects pop out on the left-hand side. Now, I've already got a subtle bloom and glare effect applied here, so let's just turn this off for a second, and you can see the effect that has on the image. Now, I'd like to explore the extremes of these effects just to demonstrate how they can change the look and feel of your image. If I increase the size, you'll notice that the fuzzy outline of the light coming from the sun increases a bit. However, we need to increase the intensity in order to multiply the brightness, and that should show us how this effect really works. Now you can see how the individual blades are much more visible coming from the light sources. Now let's increase the bloom parameter, and you'll see that the sharp blades are dramatically softened, creating more of a warm and hazy effect. And next I'm going to increase the threshold as well. This sets the threshold for pixels to be considered as a lens effect source. You can see how a higher threshold softens the overall effect and it reduces the scope as well. Now, notice here below that there's also several modes you can choose from, including options for exporting a separate render element. We can even use this render element to get a better feel for the effect. All we have to do here is switch over to the glare element. And now I'll lower the threshold and the bloom values back down, so we'll leave the size and intensity very high. And now you can see the blades very clearly. We can adjust the number of blades here as well using this control. And you'll see there's some additional controls also below for changing rotation or adjusting the angle of the blades. But I'm going to reset the bloom glare effect back to the previous settings now, and let's return to the final render. And you can also toggle the RGB switch here if you want to see the render results with and without the lens effects. Alright, now before I forget to mention it, when you're rendering with Cryptomatte, you first need to set it up to be saved in the V-Ray render settings. Let's open up the render settings and go to the Common tab here. Now at the top, you'll see in the image file output that you can set a file name prefix to save it as. For example, I'll name mine Spaceship. Next, we also need to save the Cryptomattes using the multi-channel EXR format. Click the Image Format dropdown and choose the EXR multi-channel option. Now if I press render, all of my Cryptomatte elements will be saved to the path location listed at the top of the Common tab, and they'll be saved as OpenEXR images. Okay, let's hop over into Nuke now, and I'll demonstrate how Cryptomatte can be used in a compositing workflow. Alright, I've got a Nuke file set up here already, and first I just want to demonstrate a comparison between the denoise beauty pass and the beauty pass without the denoiser. As you can see, when I switch back and forth, the denoised image is much smoother. And as I mentioned earlier, you can also denoise separate render elements. For example, I have here a denoised version of the reflection render element, and one without the denoising applied to it, and if I switch back and forth here, you can see the difference. Again, this is a great option to give you some additional control and flexibility when you're compositing. Now, let's take a look at how you can use Cryptomatte in a typical post-production workflow. You can see that I've got the Cryptomatte node, and if I select that, I can then use the picker to select a specific matte. Let's pick the ship here and then choose matte only. Now if I add a grade node to the Cryptomatte, I can apply some color corrections, such as increasing the gain a bit. And this will help to make the ship stand out a bit more. And just like that, you can make color corrections using Cryptomatte. Alright, and now let's add in some smoke that I rendered here for the ship, as well as some additional glow and lens effects. And then I'll turn on a few other color corrections here. And we'll arrive at our final image. Okay, now you've seen how we can composite using Cryptomatte, so let's move on to the new materials in V-Ray Next. In V-Ray Next, we've made significant updates to V-Ray's materials in order to make it easier than ever to get great looking results. To start with, we've introduced a brand new hair shader that is based on the real-world physiology of hair. This means that instead of simply tweaking colors to create realistic looking hair, we've designed our new shader to mimic physical characteristics. For example, you'll now have the ability to adjust parameters that affect the pigmentation or adjust the redness of hair strands. We've also added controls for glint and glitter to improve the highlight options you have as well. At the same time, these controls are still simple to work with and understand, and it makes it easy to get great looking results with little effort. Let's go ahead and hop into Maya now, and I'll show you how to use it. Okay, let's go ahead and start an IPR and see what we already have set up so far. I have a Maya scene here that was created by Ian Spriggs for his incredibly popular 3D portrait series, and he graciously shared this scene with us, and it's a perfect example of how the new V-Ray Next hair material can be put into practice. As you can see, there's already a default V-Ray hair Next material applied to the hairs, so let's play around with some of the settings now and see how we can change the look of the hair using the new shader. First, I'm going to zoom in a bit on the beard here just so we can see the hair in better detail. And the first parameter I'm going to adjust here is the melanin. So bringing this down a bit will lighten the hair and affect the pigmentation. Next, I'll draw another render region for comparison. And let's increase the pheomelanin parameter. This will increase some of the redness in the hair. Now, if I draw a new render region and lower the melanin down to 0, you'll see that we can create a gray hair look. Moving the melanin this low effectively works like bleach, allowing us to dye the hair as well. So let's try making it a bright pink color. Now, to make it look a bit less dramatic, we can bring up the melanin back to something like 0.5. Okay, now I'll redraw the render region. And let's also explore some of the randomization options we have down below. For example, I can move the random dye hue to 1, which will give me a mixed variety of colored strands. Let's return the random dye hue to 0, and then I'm going to increase the melanin from 0.5 to about 0.85. The randomization controls don't apply just to the dye. In fact, we can also use this with more natural looking hair. Now to make the subject look older, I can increase the random gray hair density, and this will blend in some gray hairs as well. As we increase this value, you'll see that more and more gray hairs are becoming visible in the IPR. Alright, let's return our subject to youth again and bring down the pheomelanin a bit. We've also introduced new glint and glitter controls to give the hair more realistic looking highlights. If I increase the glint strength, the colored highlights become more visible. And for comparison, if I increase the glitter strength, we'll see scattered highlights across the various hair strands. Okay, now I'm going to turn off the render region just so you can see how it's applied to the rest of the beard. Now you can see how the new glint and glitter controls, along with the new physical parameters, make it easy to get some really realistic looks right out of the box. Alright, now let's take a look at the new V-Ray Toon Shader. The Toon Shader offers controls for creating stylized cel-shaded and anime effects quickly and easily. Now you'll find there's even more advanced options for adjusting the line controls on the inside and outside, and you can now do this on a per material basis as well. Let's hop back into Maya, and I'll show you how you can achieve a few different looks with it. Okay, we have a scene here that has a whale with a kind of sci-fi themed cabin on top, And the whale already has a default V-Ray Toon shader applied to it, so to get started, let's explore how to adjust the global outline settings for the shader. Now, to access the global controls, I'll just simply click on the Create menu, go to V-Ray, and then choose the Create V-Ray Toon option. You'll see the controls appear in the attribute editor on the right. Now, let's go ahead and start the IPR on the viewport just to see how things look. Using the controls on the right, I can change the global line width and the line color, and let's increase the width to see some thicker lines. I'm also going to change the color to something red just to make the lines more visible. Now, if you want to have more control over the inner lines separate from the edges, simply check the inner line control box here. I'll change this to an orange color for visibility, and let's increase the width thickness of the inner lines. You can see how this gives you a lot more flexibility for customization. Now, let's turn off the inner line control, and I'm going to set the lines to be a bit thicker. And let's change them back to black so we can move on to the Toon Shaders controls. Okay, I'll select the whale here, and let's select the V-Ray Toon material that's already been applied to it. Let's enable the new Toon Edges override. This will let you override the global controls, and you'll see it has a multiplier, which we can use to fine-tune the individual line settings. So, for example, I can decrease the line width multiplier, and you'll see that my lines shrink down from the maximum width that we set earlier with the V-Ray Toon effect. And I can do this for the inner lines as well, just by checking this box. This can be done for each V-Ray Toon material you have. Now, if I pan over here to the side of the whale, I'll zoom in a bit, and you can see the effect this has on the lines much better. Yeah, that looks pretty good to me. Alright, now that we have our lines set, I'm going to show you how you can change the colors using the diffuse ramp. Moving these sliders, you'll see how we can make different parts of the ramp's spectrum visible on the whale. I can also add more sliders and adjust these to my preference. There's also the diffuse ramp offset control here, and if we increase this, it basically increases the ramp position for all the shaded points. So you'll see the shading overall is getting noticeably lighter. Now, what's handy about the offset is that we can also add in custom ramps or textures, for example. Let's click on it and add a file. And I'm going to add a grayscale image like this one I have right here. You'll see the effect takes place immediately in the IPR. And I'm also going to increase the UVs a bit here. Now I want the lines to stand out a bit better, so let's make a few more tweaks to the diffuse ramp. And as a final touch, let's increase the reflection color and lower the reflection glossiness, and this will give the whale a slightly more polished and reflective look. Alright, and now you've seen how easy it is to get started using the Toon Shader with V-Ray Next. Okay, now let's take a look at the new METALNESS parameter. In V-Ray Next, we've enhanced the V-Ray material with functionality for PBR materials from tools like Substance Painter. Since PBR workflows are popular with real-time engines, the new METALNESS parameter makes it easy to ensure consistency. Let's hop into Substance Painter, and I'll show you how to export your textures from there and bring them into Maya to use with V-Ray. Okay, to start, I've already got this metallic material set up here in Substance. To move this over to Maya, all we need to do is click File and Export Textures, and I can check under the red drop-down menu to see which textures will be exported. We'll also need to set a configuration here, so I'm going to choose the PBR Metal Rough option. Now I'll hit Export, and this is going to give us a bunch of different textures, which I can then plug into the V-Ray material in Maya. And thanks to the metalness parameter, the results will be consistent. Okay, let's head into Maya now. Alright, to get a sense of our scene here, let's go ahead and start the IPR in the frame buffer. You'll see in the preview that we've already got our object in the scene, with a standard V-Ray material applied to it. Let's open the Hypershade editor now, and I'm going to start applying some of the materials we just exported from Substance. First, let's drag and drop these into the Hypershade window. And now let's get them into position together. Alright, so the first thing we need to do here is set the color space for each material. I'm going to change the base normal color space to raw. I'm also going to scroll down and make sure that the map type is set to normal map in tangent space so that the material displays correctly. Then let's drag the base normal file into the map slot for the bump and normal mapping. Now we can go ahead and check on the Use Roughness option in order for the PBR materials to be interpreted correctly. Let's also increase the metalness slider to 1 so that the reflection mode changes to metalness to work with the substance textures. And finally, let's increase the reflection color from black to white. Next, let's set the base metal texture color space to raw, and then drag and drop the file into the metalness texture slot. Now, let's also check that the diffuse textures color space is set to sRGB, and then we can drag and drop that into the diffuse color texture slot. You can see now in the IPR that the black color and the scratch marks are starting to show. However, we still need to add the base roughness texture as well. Let's change its color space to raw, and we'll drag and drop it into the reflection roughness. Now in the frame buffer, you'll see that the material is updating the reflection from the different light sources we have in the scene, and that looks much better. Since the process is exactly the same, I've already set up the other material, and we'll just need to assign it. Alright, I'm liking that a lot. Now I'll bring over the outliner, and we can turn on some additional lights along with the backdrop, just so you can see how the material looks under slightly different lighting conditions. And that's it. With the check of a box, a few quick tweaks to the color space, and adjusting 2 sliders, you can bring your PBR textures from Substance and get great looking results right away. Okay, now let's explore another brand new material option, the V-Ray layered texture. The new layered texture makes it so that you can merge maps together with blend modes and masking controls, which makes it really easy to create complex looking textures, all with the simplicity of a layer-based system. Let's head back into Maya again, and I'm going to show you how it works. Okay, for this scene here, I've already set up an asset with a V-Ray material, so to get started, we'll just simply click on the diffuse texture slot and add the V-Ray layered text node. Now let's start the IPR so we can add and adjust the layers with feedback, and we'll need to add a new item to start. Clicking here will give us our first layer, layer 0, and you can see it gives us options for textures, masks, blend modes, and opacity. I'm going to click on the mask texture slot to add a file node, and then we'll load in the metal rust mask PNG file. I'm also going to adjust the UV tiling here to 6. Now we can change the color of the texture if we want. For example, I'm going to change it to a slight hint of blue. Then I'll decrease the opacity down to something like 0.15. And now we can continue to build on top of this layer. So let's go here and add a new item and add another texture mask. Note that the higher number layers we add are layered on top of the lower number layers. And this time I'm going to choose the metal painted mask PNG. Now, back in the Layers tab, I'll darken the color some. And let's also change the blend mode to screen. These blend modes work similar to other layering softwares. Now I'm going to decrease the opacity a bit to something like 0.5. Okay, and let's add another layer. And add a mask. I'm going to now add some decals to the object. Now they aren't very visible right now, so let's change it to this bright orange color that I know works for this scene. And I'm going to change the blend mode to add and bring down the opacity to make the decals appear more faded. And let's settle on 0.2. Alright, now let's add one more layer. This time, instead of using a texture as a mask, I'm going to select the V-Ray dirt texture. This can be used to simulate, obviously, dirt, but also things like rust, or even just to simply create ambient occlusion. First, let's invert the occluded and unoccluded colors. That way the lower layers appear visible, and the V-Ray dirt layer appears only in occluded areas like the crevices. Next, let's increase the radius a bit, and now I'm going to increase the fall-off some, so you can see how this affects the transition between the occluded and unoccluded areas. Let's set the radius to 6, and set the fall-off to 3. Okay, now back in the Layers section, I'm going to make a few last tweaks by bringing up the color to white, setting the blend mode to multiply, and I'm going to change the opacity to 0.5. Alright, now you've seen how with a few tweaks to the blend modes and masking controls, you can use the V-Ray layered texture to create a complex result. We also now support layered Alembic workflows with Alembic 1.7. Now you can transform Alembic proxies by adding layers on top in order to do things like override properties or UV map objects that don't have UVs and more. And in V-Ray Next, we also support VRSCANs, which includes access to a library with more than 650 materials. On the website, you can sort from a large variety of material types such as metals, plastics, fabrics, and more, and you can also sort using multiple options. For example, let's say a red car paint. I can then take a look at the material up close and get a preview of the scan, and if I like it, I can simply download it and plug it into my scene. In fact, I'll even demonstrate what a scene might look like if it were using entirely VRSCANs in Maya. Alright, in this scene, I'll demonstrate how VRSCANs can be easily applied using the VRSCAN material. First, let's open up the render settings and just take a look at what we're using here. I've got things set up to render on the GPU, as VRSCANs are supported for GPU rendering as well. Let's open up the Hypershade editor now, and I'm going to take a look at a few of the different VRSCAN materials I've got set up. As we just saw on the website, let's start with this red car paint here. If I pull up the graph network and select the material node, you can see there is a VRSCAN material file that's loaded in the attribute editor. Alright, let's take a quick peek at a few of the other materials. We've got, for example, this blue fabric material here. Again, I'll show you how simple the node setup is. You can see there are many more materials here that I can also give you a quick glimpse of. Again, all of these taken from our website. Okay, let's go ahead and close the Hypershade editor and the render settings. And then let's start an IPR preview. And in addition, I'll note that we do support triplanar mapping with VRSCANs, and that makes it really easy to map materials to objects since you don't have to fuss with the UVs. Alright, now we've got a preview going here, and I'm just going to let this render a bit so you can see the GPU rendering with VRSCANs in action. Now I'm going to stop the render, and I'll show you that the VRSCANs also work with the render elements. You can see here, for example, we have the lighting, the reflections, and the global illumination. Now you've seen VRSCANs on GPU and how easy it is to set them up to render photorealistic textures. Last but not least, we also have our new push-button V-Ray Cloud service, which you can see in action in this video here. Simply press the V-Ray Cloud button in Maya, and your entire scene will be uploaded to the cloud, and you can have it rendered in minutes. You won't have to worry about setting up anything complicated. Just give the job a name and press Submit. And you can monitor its progress right from the website and download it when it's ready. Alright, to sum everything up, we've covered the different ways that V-Ray Next is smarter, faster, and more powerful than ever. You'll have support from adaptive algorithms, scene intelligent tools like the adaptive dome light. You'll see speed boosts thanks to the redesigned IPR and the brand new multi-kernel GPU architecture. And you'll also be able to take advantage of a ton of brand new tools to optimize your workflow. We've got brand new materials, UI improvements, and GPU enhancements like support for Cryptomat and volumetrics. If you'd like to try out V-Ray Next for Maya, we have a 30-day free trial that you can sign up for on our website. Just visit chaosgroup.com for more details. If you have more questions about the features we covered, please don't hesitate to check out our docs page as well for more detailed explanations about our products. Lastly, if you enjoyed this webinar, please feel free to subscribe to our YouTube channel, Chaos Group TV, for the latest news and release updates. Thank you for joining me for this session, and I hope to see you next time.